Yeah, welcome to another presentation on concepts of random variables. In previous presentation, we have seen the very important parameter which is the expected value of given random variable x. The expected value of given random variable x. How the expected value or the mean value or the average value can be determined, that we have seen in our previous presentation. In this particular presentation, I would like to solve a very important model question which is normally can be asked in GATE examination as well as any other technical competitive examinations by central government or otherwise state government, right? So now this is a simple example which I am going to explain in this presentation. Let x be a continuous random variable with PDF, means probability density function of random variable x, that is denoted by f of x, I mean small f of x is equal to 4x cube, right? 4x cube, and this function f of x is defined for the interval 0 is less than or equal to small x is less than or equal to 1. Means that what, these are the limitations of the small x, means that is the limitations of the possible values of f of x, means that the density function is defined within this interval only, 0 to 1, between 0 to 1. Outside of that limitations, okay, the f of x value is 0, right? So in between these two intervals, in between 0 to 1, the f of x value is defined as like this, 4x cube, and outside of that boundary this value becomes a 0. Now you are asking that find out the expected value of random variable x. What is the expected value? E of x. Okay, so this is the very important model normally you can come across in GATE examinations. So how this problem can be solved, right? So I will solve this question, right? Let us see how this can be evaluated. A very simple question, actually very important model. So for this what we need to do, the expected value. So what is E of x? We know that E of x is equal to, is it not? What is E of x? E of x is equal to, it is, what is the formula? It is minus infinity to plus infinity small x into f of x into dx. This is the formula for a continuous random variable, because in the problem itself it is given as that capital X is a continuous random variable. So if it is a continuous random variable, there is no doubt you have to take the integration only. This is the normal formula. In this formula, so these are the x values, actually x is equal to minus infinity to plus infinity. The limitation value belongs to x because we are defining this function for random variable x. Therefore this integral or this integration is evaluated with respect to dx, means that what, you must know the limitations of x which is already given in the problem. Okay, therefore what are the limitations you are mentioning here, that is minus infinity to plus infinite, those are the values of x only. I think you got it, right? Next, now what are the limitations from the problem? So the x value, the small x value is defined between 0 to 1, therefore integral value is 0 to 1, right? So x is already there as per the formula, x you must write the x. And what is f of x? F of x is already given in the problem. What is that f of x? It is 4 times x cube into dx. Clear? So x is as per the formula, x we have to write. F of x is nothing but density function. It is your small PDF. That is nothing but 4x cube, right? So problem is over. So if you evaluate this integration, then whatever the value you will get, that is itself is the expected value, and therefore this is equal to, now it is 0 to 1, right? So 4 is a constant, so this is x into x cube. How much? It is x power 4 into dx. In the next step, you can write 4 outside. It is 0 to 1. It is x power 4 into dx. What could be the next step? What could be the next step? If you evaluate further, you will get the value as, right? If you evaluate, it is expected of x value we are calculating. So this is equal to, it is 4, is it not? 4 into, what is the integral of x power 4? We know that there is a formula, integral power x power n into dx. What is the formula? X power n plus 1 by n plus 1. Remember that this is the formula. Integral of x power n is equal to x power n plus 1 by n plus 1. So according to this formula, x power n, what is n value? 4. Therefore put a bracket here. Therefore, if you substitute, or you can simplify with respect to that, this is x power n plus 1. What is n value? 4. 4 plus 1. It is 4 plus 1 by 4 plus 1. Now 0 to 1 limitations you must substitute here. Clear? And afterwards your problem is over. This is equal to 4 into x power 5 by 5. It is 0 to 1. This equal to 5 is in denominator, take outside. So it is 4 by 5 into, in x power 5 you have to substitute. So x power 5 will be there, 0 to 1, and this implies it is 4 by 5. Therefore substitute upper limit, means in place of x substitute 1 first, that is 1 power 5 minus lower limit, is it not? So upper limit minus lower limit. So okay, so at this x you substitute 1 first, that is 1 power 5 minus, again in place of x substitute 0, so 0 power 5. This is equal to how much? It is 4 by 5. So 1 power 5 is how much? 1 only. 0 power 5, it is 0. 1 minus 0 is 1 only. It is 4 by 5. Therefore, what is your answer? What is your expected of x? It is 4 by 5 only. So this is what your mean value, right? That is what your mean value. Therefore, that is your answer. That is your answer. Therefore, E of x is equal to, the expected value for the given PDF is equal to, it is 4 by 5 only. This is your answer. So there may be options will be given A, B, C, D, like that, right? So this is very, very important model. Okay. So with this, I will finish off this particular presentation and we'll see some more examples in our subsequent presentations, right? So thank you for watching this video.